Today, our discussion focuses on how to publish possibly groundbreaking works. This part consists of two parts. Now, warning, any discussion on such a topic has its limitations because the discussant is always constrained by his scope of knowledge and experience. What is presented here is based on my 30+ years of thinking and practice on what could be groundbreaking in the world of learning. Now, this entire discussion or thinking along this line really started from my very beginning of my academic career and how I become awakened. Now, the importance of publications for a professional initially hit me when I completed my first year of college. During that year, I tried way beyond my best in order to score the highest in every class I took, and sadly, I failed this attempt. And no matter which class I look at, there always seemed to be someone who scored better, except a few instances. In that year though, even though I did not score the highest in every class I took, I still came across several very established scholars. One of them stood out as very friendly, yet extremely arrogant. So, to me, as a student, I did not understand why. So I consulted with other professors, and from other professors, I learned that this professor is very well known and recognized through his publications. And his achievements, shown by publications, opened the doors of opportunity for himself, for his department, and for the entire university he worked for. So, just looking at this professor I have, I decided I'm going to match up to him. Once again, after many attempts, I realized my desire to do so once again failed miserably. The failed attempts first tried to score as high as in every class I take, and second tried to match up with my professors by publishing my own papers. I failed both attempts, and then these failed attempts made me realize that what I learned in school and what I try as a regular student would not make a much impact in my future careers. So I realized what's important is I have to make myself, my own thoughts known by others through published papers. Only such thing would really matter in my future careers. So, because of this realization, I shifted my focus from trying to be the best student in classes in terms of grades to trying to establish myself as an academician. And along this line, I tried very hard and tried to find how. And nearly 4 years later, one day in one of my graduate level philosophy classes, a classmate made a joke based on what the teacher was teaching us. At the moment, the teacher was explaining how to do parallel thinking in scientific research and in technology research. Okay, And this joke from my classmate really enlightened myself. And I realized a parallelism between two completely unrelated studies. One is the naive set theory, and the other is this so-called science of science my philosophy teacher was discussing to us. Now, what is set theory? About 100 years ago, or 130-40 years ago to be more exact, set theory was introduced in order to provide the badly needed foundation for the edifice of mathematics. On the other hand, science of science attempts to study and manage all activities of science as an entity, as a business enterprise. Such idea is quite natural if we look at the development of science and the importance of scientific research from the angle of collectivism. This idea is really quite natural. Now, for naive set theory, it was initiated by George Cantor in order to build a foundation for mathematics. Now, people would say mathematics has been in existence since quite the beginning of human history. Then what is wrong with the foundation? And throughout the history of mathematics, the foundations of mathematics experienced several rounds of crises. The latest one, before George Cantor established set theory, was related to the concept of limits used in calculus. And then further study of related matters of calculus reveals the fact that the foundation of mathematics is still lacking. Okay, in his set theory, he defined the concept of set as a collection of elements or things. So a natural question arises. If any collection of objects is a set, then how about the collection of all sets? Is such a collection a set? By looking at this problem, Bertrand Russell saw a parallelism between the concept of sets and age-old paradoxes in philosophy. So in 1901, he constructed his well-known Russell's paradox and showed that the naive set theory suffers from a major inconsistency at its very elementary level, by showing that the collection of all sets is not a set. Okay, here the word inconsistency really means the set theory at its very beginning level contain contradictory conclusions. Now, this kind of phenomenon is very surprising in the area of mathematics, because the whole public and society, and including mathematicians, believe mathematics is a cohesive, self-contained, and consistent theory. Within such theory, there should not be any inconsistent results or contradictory results. And so this Russell's paradox really led to the third crisis in the foundations of mathematics. And also, because of this Russell's paradox, Bertrand Russell was awarded the Nobel Prize in Literature. up to this point, Russell is the first mathematician and only mathematician who ever won Nobel Prize based on his work related to mathematics. Now let's look at the science of science. It is defined as such a science that investigates all sciences. So there is a clear parallelism between the concept of sets and the definition of science and science. So it is quite natural to believe that the science of science, as defined previously, cannot exist as a science. Now, how do we establish this belief, even though intuitively now we can see it is the case? So to convert the belief into a theoretical result on sound logical reasoning, a new language is needed that can help translate the language of naive set theory to the setting at hand. And by looking around available choices, system science is naturally chosen because system is a collection. Each system is a collection of objects connected by relations. Now, each science, as a consequence of this choice of language, we can see that each science can be understood as a living system with all basic concepts as the building elements and the conclusions as the relations of the elements. Okay, then an argument which is similar to that used in Russell's paradox is established to show the following result. The science of science cannot exist if it is defined as such a science that attempts to study all sciences. So after we establish the previous result, showing that the science of science cannot exist as a science, then what's next? With colleagues, I just moved on to establish new results in system science and applications in philosophy, sociology, and material science. How do I know I could establish new results in system science? At the moment, it was very straightforward. The reason is when we convert known concepts and conclusions of systems research to fit the setting in order for us to prove the science of science cannot exist as a science, we have to introduce some new concepts and slightly modify some of the conclusions known in systems research. And so that gives us a clue that further works along that line can be done. Then why do we think about applications in other areas? It is again, we strongly feel the work we started could be groundbreaking, but how do we prove that? To support that end, we have to establish very, very significant applications. So this is what we did in those three directions at the moment over nearly 20 years ago. The application in philosophy shows why the material world is finitely divisible, and the problem whether the physical material world is finitely divisible or infinitely divisible has been around since the time of Aristotle. So you can imagine it has been around a long time. And the application in sociology established procedure on how to develop a successful school of thought. And the application in material science provides a systemic model that describes the elementary structure of polymers. So here, to generate groundbreaking works, flexibility turned out to be very important. Okay, the desire to publish groundbreaking works is most challenging because you have to guess what is important, and also we have to jump from one topic to another in order to capture such a potential possibility that we can create groundbreaking works. And to make this desire a reality, it really requires us to be flexible on what we might be working on. The reason here is that we never know what conditions and convenience our working environment offers us. To this end, let's use an example to illustrate what we are talking about. Now, this scholar named Adolf Quetelet, who lived during 1796 through 1874. He was really a mathematician by training because he dreamed of becoming someone like Isaac Newton. So instead of mathematics, he chose astronomy as his future career direction. And to materialize his dream, he immediately realized what's important for him is to establish an observatory. And with a great effort, in 1823, he finally found enough support to build the Brussels Observatory, with himself being the director. And since astronomy was a new field to him, he visited other European observatories and learned all the relevant knowledge. When he's finally ready to embark on his new journey in 1830, he realized he received the following bad news. A revolution just broke out, and the Brussels Observatory was taken by the revolutionary forces. The social turmoil put his future in jeopardy, and he could not do anything for now. At the same time, he did not know whether the new government would continue to support his effort. Okay. However, for Adolf, instead of being distracted by the social unrest, he actually faced the situation and challenged himself by asking the following very meaningful question. Is it possible that he could develop a science that can help manage the society by using similar principles that are used to investigate hidden patterns of the heaven? By thinking along this line, and by using the knowledge of astronomy to study the dynamics of human behaviors, Adolf established his theory of social physics, and that became the start of the field today we know as sociology. His idea of using statistics to investigate human behaviors, herd behaviors, and human commonalities become very well accepted in the world of learning. And now history honors Adolf as a Belgian astronomer, mathematician, statistician, and sociologist. Alright, in order not to make this discussion too long, let's stop here for now and leave the rest of this discussion on this topic to the next episode. Please direct your comments, questions to my email. I truly love to hear from you, and I will discuss your comments and questions in our following videos. Thank you very much.